All right. Okay. So let's start translating into model. I hate this. What is this? Mining is. What the hell is this? Okay, let's ignore that. Um, moving forward. Now that we have a pretty good idea, good high level idea of how a checklist gets used within our domain, we have to decide how we'll model it. This is a tricky part of the process. From our high level understanding, which is described by just those few loose sentences in section 4.4, this guy, in listing 4.4, we have to abstract out a set of attributes which, when combined together, capture the core essence of what it means to be a checklist. In the previous chapter, we approached modeling in two distinct phases. First, we wrote down what we knew about the meaning of our data. Then, once we were sure it was clear, we swapped over to writing code. This lets us use the meaning of data to guide the design of our code. In this chapter, we will go with a less strict approach that freely moves back and forth between the two phases. So, writing down what we think it is and coding, I guess. This is much more representative of how I would approach modeling a new domain. We'll sketch out a few records and then take a step back and look at it from the meaning perspective. Then swap back to code to sketch some more, take another step back, move things around, etc., 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 etc. The main point I want to stress here is not to think of the process as actually writing code yet. We're using code purely as a canvas for our thinking. Right now, it's wet clay. It's malleable and coarse. We definitely won't build anything on top of it yet. We're only sketching. We'll add, remove, shuffle it around as we explore how each change affects the meaning our data conveys. So, let's take a stab at lifting out a set of attributes from our current understanding that we can use to model these domains or ideas. So we have steps is complete. Well, I do not have that. I have like a task. Here we can say, okay, that amount. So these done on complete. So this is gonna be our steps, right? So this is our steps, and he wants us to have like whether it's complete. Why would we have like, is this step complete? Okay, I know. Okay, so let's say boolean, I guess, is complete. Doesn't feel right, but it's complete. What? Fine A. And here, complete. Right? Is complete. Alright, we can start here. But let's first tackle the templates. Alright, so which is this guy? The model collection of things to do. We already took a stab at modeling things, right? As a record called step, or the things to do. Stab at modeling these things to do as a record called steps. Okay, so this or this, which one is it? Things to do as a record called steps. Okay, so things to do are called steps, right? Okay. In listing 4.1, so we could plot that in as a starting point. All right, so we have steps, and in our templates we have this. So task. All right, so task are our steps. We might not keep it, but that's okay. Throwing things out is part of the process. For the templates themselves, they're just collections of things grouped under an identifiable name. All right, so in templates, we have like a subject. I would say I want to keep it like a subject, so let's say string. What did I do? I'll have like string subject, like that, where subject is like a subject is equal name, right? So just a note for myself to not get confused. Tasks is gonna equal steps, right? That's what these are. And task name, I don't know why we have like, I don't know why we have task called, we have a name. So like steps have like a name, and then it's completed, and then a template has, let's go back to the sketch. So I guess when you say a task, a step, you're saying here, right? What is the name of this task? Step is gonna be this, that's the name, okay? And then whether it's completed. I do not think though it should be here, right? I will take this out. Find B, I'll change till here. Good. I do not believe that. I think it should just be that. My step should just be that. It shouldn't have a name yet. It should just have a name and that's it. And have a list of names and that's it. Now when we have a running instance, we're gonna create like a status. This is gonna be whatever. We have this status is completed, blah blah blah. And when we, something, I don't know, but this looks right to me. I don't have like a template. A template doesn't have that, right? Template or a task doesn't have that either. Okay, all right. Throwing things out is part of the process. For the templates themselves, they're just collections of steps, of these steps grouped under an identifiable name. So we might sketch out all of this like this. So you have a name, blah blah blah. So template is gonna have a subject, and then we're gonna have the subject is kind of like a title of what to do, right? So we can say a subject or a title. That's how I think about it. Or should I say a title? Maybe call it a title. Title. Right, like we have like a title or something. Cool. Templates should reside in a container that tells us whether it's done or not. So a template resides in a container, right? So a container, right? So this template, so we're gonna take this so kind of like a map. This task should tell us whether it's the status of it. For each in this, right? We want it for each title. We want each task to point us to whether, if it's a running task, to point us to whether it's completed or its status, right? So let's say we have, that's me thinking out loud. Let's say we have something like this, right? So I have like a for each task point us, what is this, to point us to status of the task. You know what I mean? Like that. For each task, point us to status of the task. Task. For each task in tasks. For each task in task, point us to status of the task, right? So it's kind of like you're looping and then you're saying for this, what is the status? For that, what is, that's my imagination. But let's go back. Where were we? Okay, yeah. I do not agree with this part of it because steps doesn't tell us anything about that yet. It's pretty good enough to start, but it's nowhere. It's not where we stop. I'll keep belaboring the point. We're still in the exploring design phase. We're using code as a thinking tool. We've written a little code, so now we take a step back and see if the code is capturing the meaning of our data. If we review our definition from listing 4.4, we've said that a template is a named collection of things to do. It only cares about what the steps are. It doesn't say anything about how they're used or completed over time. However, in our code says something different. We've got this is completed idea hanging. What the hell, man? Jesus Christ. Hanging around in there. It's superficially small, but this coupling allows our code to say rather weird things when we're constructing templates, right? So we have a template, create a new template. I hate that. Okay. We say the template's name is going to be from their template's name, international travel, and it's going to have a list of steps, right? Blah, 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 blah. So this, yes, we want something like this, right? But this should just tell us something. If we focus on the code, we could probably get away with this modeling, even though it doesn't quite line up with what we've defined a template to mean. So he's talking about templates still, okay, instead of steps. However, we have to be extra cautious of falling into this trap. We always have to use the meaning of the data to guide us through our design phase. Without it, pesky code thoughts can start to invade our thinking. These code thoughts usually start with something innocent sounding like, well, we could just blah, right? But where the just part is usually defensive programming in other parts of our code to walk around the problem being introduced in this part of the code. For instance, upon seeing the strange socks are already always packed problem, socks are already always packed. Socks are already always packed problem. It could be justified as well. We could always just ignore what is in the template, and I don't know what this is. What? I don't know what this is or what it means. For instance, upon seeing the strange socks are already packed problem, it could be justified as, well, we could always just ignore what's in the template and do this. We could always just defensively make sure that new instance, so we create an instance template that streams, so it's going to stream all the list in the template. A template, what is a template? Okay, so we have steps, so we take the steps part of our text, new step, and we take the name and then just put it to false, then to list. Okay, all right, but let's not fall into this trap. We want our code to enforce its own meaning and help us, the fallible programmers, not make mistakes. So rather than patch around, so this is saying, okay, this is always true, we can just make everything false. So rather than patch around this modeling problem with defensive codes, let's remove the problem entirely by just using better modeling. Of course, we don't quite know what the better modeling looks like yet, but we do know what's wrong with this one. It allows bad states, so let's take its complete out of that. So steps, like I did, because it just feel it never said anything. Like if you check, the template never said anything about whether something is completed. It just has a title and actionable items, and in our actionable items it still hasn't said anything. It seems like it comes later on, right? That's why I did what I did. So we took it out of the steps. Now we have to figure out where to put it. If we flip back to our definitions in listing 4.4, it's the instance of our checklist where we record the individual steps as completed, not the templates. So these are the things that we do. So this, I think this template is, so maybe if we tackle sketching out a model, for instance, we'll find where to put it there. All right, so we have like this, and from here, checklist is, well, a running number, like an ID. Okay, so let's do an instance. 2 is gonna be an instance, right? So we're gonna create a record. We're gonna say instance, and it's gonna have an instance. So there's a running number, ID, status, instance. It's gonna have like a template, right? So let's look at this diagram. Our diagram here has like a running number. So can the number be negative? No. So I'm gonna say, I'm just gonna give it a UUID. UUID. Call it an ID. And what I know is that it has a date, maybe date time, and then it's gonna have a template. Template called template, right? That is what I know it to have. Okay, I think it's gonna be UUID. I don't know. UUID, and what is this? Could not find. Okay. I think it's date. maybe that date. Or is it time? I have no idea. I cannot find. I don't know. Where is date time from? Let's go with this date. Until this. Let's go with this for now. This fucking asshole. Sorry. That's my cat. Always disturbs me. Alright. So we have that, right? And let's see, does it say anything about anything in progress? And we have like an in progress status. Maybe job. So let's create a. I'd say this. I'll prefer. I like enums, so enum is status. It's gonna be like in progress complete. Something like that, right? It should be something like this. All right. So I would like to know. So let's say status. Give it like status. Right. Date. Actually, right. Day. Like that. Good. So we have that. This looks more. So we have an ID. We have what it's completed or in progress. We have a date, and we have like the template, and the template carries the title and the list of things to do. Now, this tells us whether the whole thing is done. These template has to have something else, right? This template, like, we don't know. Currently we know only if the instance is done, right? If it's in progress or if it's completed. However, we want to know if each of the item here is done. So I think this is going to end up getting removed and put inside a container of its own, because we want to know if the individual tasks or steps have been completed, right? And that can be true or false. Cool. So I think we are here. Instant date. Okay, that's cool. The modeling of the instance feels okay, but it's still not immediately clear where something like is completed but fit. It's tricky. It definitely feels like a step and its status belong together. But we know that where things happen if we attach the status to the step directly, like we did back in listing 4.6, our template starts to say nonsensical things. So we might try going the other way, introducing a new type. Which can hold a step, a status. So a status should hold a step, a task. Okay. All right. Okay, that kind of makes sense too, right? Like, we can say task status. What's that? Status, right? It's gonna have like a boolean, like a step, or should I say a task? I'll call it a task. It's gonna have whether the task is completed, right? So we'll have boolean and is completed. Right, so for each task we want to be able to know if it's completed. So we're gonna have that, right? Okay. And this is equivalent task status equal to what's it called? Status in the book. Cool. Just for my sanity. Alright, so template now. So now we know that one, we can have that. And then I am guessing this has to change. We'll have a list of if this task has this, then wouldn't template just be a list of task status? Ooh, this is weird. Trying a new approach using a new type to do whatever feels pretty good, but we still haven't tied it explicitly to our instance. But maybe we don't need to. Every model we create is an approximation of the real world. It needs to capture its meaning, but it doesn't need to match its shape. So what if we just left statuses as their own model and reference them elsewhere as needed? One argument for this approach is that these status records will be the main thing that gets continuously updated as our program is running and people work on their checklists. All other data, once it's created, is completely static, so it doesn't change. So we might embrace that fact and let statuses be their own thing, which can be stored and tracked in whatever form makes the most sense for our program. So we have our my cool checklist in memory storage. So a step is gonna be matched to a status, and then we update the status, I guess. All right, so okay, it's time. Ay, 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 look at this, it's a lot. rest. So we're gonna create a status. We've written some more code. So here's where we flip back to thinking about our data's meaning again. It is the meaning that we want to drive the design, not just what feels right with code. So let's ask something fundamental. What does it mean to be a step in a checklist? For instance, do we need to be do we do they need to be unique within a template? What about across different templates? A checklist for international travel and a checklist for a local weekend getaway might both have a step called pack socks. However, you probably wouldn't have the same pack socks multiple times within the same template. This meaning of steps tells us about some important constraint we need to enforce. But it also gives us feedback on how we've designed our status type. We didn't model it with enough information. In order to correctly tie a status to a particular step, we also need to know the template to which it belongs. So we need this step is completed, blah blah blah. All right, we're gonna come back to this. So we have a step, and then we have a list of steps in our template. So instant date, we have a template, and then we're gonna pass it this template and the step, and then we know it's completed. What about the rest? To keep things brief-ish, I've purposely left all of the constraint out of the example code. This means that our types are very similar to those we started in chapter 2. Loose and dependent on implicit assumptions in order to be correct. For instance, all those strings are suspects as usual. Should they be completely unbounded with 12 fire emojis be a valid template name in our domain? It'd be cool if so. What about making sure our steps are unique within a list? That's pretty fundamental requirement for which it means to correctly construct a template. I leave all of these constraints as an exercise for you, the reader. You should take a stab at turning the loose sketch we made into a code which brings us to guard its own constraint, which knows how to guard its own constraints. Along the way, you might find that certain modeling decisions we made here forces us to do some defensive validation during construction that itself might be eliminated by alternative modeling. We didn't go down some of these parts here because they rely on more advanced technique which we'll explore later in the book. However, learning to see this defensive code can be swapped for better modeling in one of the most valuable skills we can develop as programmers. So the more we practice, the better. Let me take a stab at this again. I leave all of these constraints as an exercise for you, the reader. You should take a stab at turning the loose sketch we made here into code which knows how to guard its own constraints. Along the way, you might find that certain modeling decisions we've made here forces us to do some defensive validation during construction that itself might be eliminated by alternative modeling. We didn't go down some of these parts here because they rely on more advanced techniques, which we will explore later in the book. However, learning to see where defensive code can be swapped for better modeling is one of the most valuable skills we can develop as programmers. So, the more we practice, the better. That's what this is. We will recap this and do more of that because we are not done. But that's the end of it. Thanks and see you again.